Here's an example of trig substitution integration question. We see that we have square root of a constant minus an x squared, and we know that we are going to be able to substitute now x equals a sine theta. So what is a again? Well, this is actually, this 3, right? 3 is actually a squared. So a is the square root of 3. Okay, only dealing with our positive roots there. So a is root 3. Okay, so then that means I'm going to let x equal root 3 sine theta. X is going to be equal to root 3 sine theta. Okay, so very similar to the one we did before, except we're going to have this not friendly irrational number here. Okay, so let's rewrite this. So we've got root 3 minus, and I'm going to put in root 3 sine theta in there, and we're going to square that. Okay. Now again, dx, right? Don't like the dx. Got it, because we're changing. We got x rid of x from this expression. So I need to now figure out what d of x is in terms of theta. So this is going to be what? What's the derivative of sine? It's going to be cos. So we have root 3 cos theta d theta. Okay, so let's rewrite this. Let's get rid of this x dx. It's actually going to look like this: square root of 3 minus, may as well square this. It's going to be 3 sine squared theta, and it's going to be multiplied by root 3 cos theta d theta. Alright, we alright with that so far? I can do a little simplification over here with that radical, because again, we want to get rid of the radical. If we're substituting properly, we should be able to get rid of the radical, which is definitely what we want to do. So, integral of, so let's take a 3 out from inside this expression. So it's going to be 3 times 1 minus sine squared theta times root 3 cos theta d theta. So we're going to be able to write this as the square root of 3 times the square root of cos squared, right? So let me just write that out here. That 1 minus sine squared is actually cos squared theta. Right? So I'm just kind of showing you all the steps here. So we can simplify a few pieces here now. So the integral, so root 3 times root 3 is just 3. Square root of cos squared is cos. And I have another cos theta here, d theta. So 3 cos theta times cos theta times d theta. Alright, so this 3 can come out. We're actually taking the integral of cos squared theta d theta. And we've successfully gotten rid of our radical sign. You know, the integral of cos is really easiest. It's you know, it's sine, but the integral of cos squared, right? Not as intuitive, but we remember we did a question just like this just a few moments ago, and so we actually can write this as the integral of cos theta d theta is actually was it 1/2 cos theta sine theta plus 1/2 theta plus c, of course. We'll remember that plus c at the end, but we're not really done so far. We've integrated, great, good job, but we've integrated while having that theta, the trig functions with theta in there. So that's kind of, we're not kind of done. We need the integral in terms of c dx, you see. So we need to go back now, and we need to rearrange this, put this in terms of x. So let me just make a little bit more space. I'm taking up a lot of space here today. So this really is, you know, it's 3/2 cos theta sine theta plus 3/2 theta. You can bring that 3/2 right out as well if you want. But we need to find out how to rewrite sine, cos, and theta in terms of x. Got to get rid of those. So again, like we did, we went back to original, okay, so look at this. So x actually equals root 3 sine theta. So we're going to use that to do our conversions and to change everything from sine theta back into x. So let's write that down here. X equals root 3 sine theta. Or sine theta is x over root 3. Okay? So that's what sine theta is. Good. We've got sine theta. Awesome. I need to figure out what cos theta is, and I need to figure out what theta is. Well, I can figure out what theta is right away, right? I'm taking the inverse of sine of both sides. And another name for the inverse of sine is arcsine. Okay, so you'll see that a lot. So arcsine, which is what this really is, of x over root 3. Okay? So now we've got theta. Now I need cos theta. And again, the key to finding these other trig functions is the right triangle. So let's draw a right triangle. Okay, and let's say we have an angle of this right triangle is theta. I know that sine of theta is x over root 3. So sine is opposite divided by hypotenuse. So I've got x over here, and I've got root 3 over here. I know that. Opposite and hypotenuse. I can complete this, okay, because I don't know what this is here, but I know that this here squared plus x squared equals root 3 squared. That's Pythagoras' theorem. So this little thing right here is actually the square root of 3 minus x squared. See that? When I solve for that. So this unknown is now known. That is this little thing right here. Okay. I'll just move that over there. Ooh, that's weird. Okay. So is everybody good with that so far? I mean, that's pretty much it now. We just substitute our values in and we're done. We got our answer. So cos. Okay, let's actually state what cos is now then. So because of our SOHCAHTOA, right? Cos is actually the adjacent divided by the hypotenuse. So cos of theta, which is what we're looking for here, now is equal to adjacent side over hypotenuse over root 3. So now we have our cos. So everything's in terms of x, so there's sine theta, here is theta, and here is cos theta. So we just simply put everything in, simplify a little bit what we can, and we should be done. So we've got 3 over 2 times cos theta, which is root 3 minus x squared over root 3, times sine theta, which is x over root 3, right, plus 3 over 2 arcsine of x over root 3, and then plus c. So to go ahead and finish that off, again, just a little simplification, I guess we could do 3 times root 3 is 3, so that gets rid of that 3, I guess. So we have x over 2 times root 3 minus x squared, and then plus 3 over 2 arcsine of x over root 3 plus c. I think that's the right answer. I have no idea, I don't have the solution in front of me at all, so hopefully we didn't make any little tiny mistakes along the way. Anybody notice any little tiny mistakes we made along the way in the math or anything? Because I think I'm pretty happy with that answer. Okay, so that's that. Again, big picture. Choose the appropriate trig substitution to go with what you see inside there underneath the radical sign. That's your tip. Okay. And then once you substitute, write everything in terms of theta, then you can integrate a little bit easier, and then you need to put things back in terms of x, and that's your answer. Okay. Here's another example that we'll do here, and this has we're integrating here now using trig substitution, but this is not in the form of the sine, which we one we just did. So this one is which form is this? 1 plus x squared. Where do you see that? Where do you see that in our patterns here? Or let's go to this one right here. So 1 plus x squared. You see that? So we're looking at the tan function here for this one. Okay? Looking at the tan function for this one. All right. So because we have 1 plus x squared, and we do have this other x squared over here, but that's okay. We're going to be able to solve for x, right? We're going to have what x equals. That's no big deal. We'll just throw that in there as well. So x equals, it's going to be a tan theta, correct? Now what is a? Well, a squared is 1, so the square root of 1 is, yeah, it's just 1. So x equals tan theta.
Sorry, where did you get A from?
Well, okay, so where do we get a from? Okay, so remember the pattern here, this is the pattern for substitution. When we have a constant plus an x squared,
Oh, okay.
you substitute a tan theta. So a is the square root of whatever that constant is. Make sense?
You don't have to look at anywhere else. And then
No, you don't have to look anywhere else. Just look underneath the root sign there for those values, absolutely. Okay? Okay, so again, we're going to have to find out what d of x is in terms of theta, so we may as well do that. You guys remember what the derivative of tan is? Nice. Secant squared theta. Okay, so we're going to be able to do that, and let's do that all at the same time here. So when we substitute, we'll do this dx as well. Okay, so let's do some substituting now. So x squared, well, x is actually just tan theta. So we're going to do 1 over tan squared theta. Does that make sense? Because it's x squared down there. And I'm just going to substitute x for tan theta. So 1 plus, this is tan squared theta. And because we want this in d theta, let's write dx as secant squared times secant squared theta d theta. Okay. All right, so you may be thinking, wow, this looks like it's going to get more complicated, but actually you're going to find here this is going to actually turn out pretty good. So you have the integral of, so let's just write the secant squared theta on top, I guess, and we'll do the d theta on the side. So we have tan squared down here, and then what's 1 plus tan squared? That's a Pythagorean identity, right, or a variation of the Pythagorean identity. That's actually secant squared. Okay, so this is actually the square root of secant squared here. So based off of our, just a little quick aside here, based off of our Pythagorean identity, if you divide everything by cos squared, then you get this variation of the identity right there. So, moving on. This turns into the integral of, and again this is secant squared theta over tan squared theta times now secant theta d theta. And of course you see that this one of those secants goes with one of those secants on the bottom. Tan squared, okay, so we can rewrite secant squared and we can rewrite tan squared. So we can do all sorts of simplification here. So secant squared is actually 1 over what? Cos squared, right? So that's like putting cos squared on the bottom. Tan squared is actually sine squared over cos squared. So because it's in the denominator, we can just flip that and it would be cos squared over sine squared. All right? I'll just make sure I'm following my own.
Oh, wait, don't you get rid of the square? For the secant.
Secant squared. So tan squared is, it's cos squared over sine squared. And one of these is just,
The one on the cos on the bottom should just be cos.
yes, thank you. That should be just cos theta. Yep. And then, so now what you see, good catch on that one. So now what you see then, the cos squared over cos is just cos, right? Cos theta over sine squared theta. Yeah, d theta. So that's as simple as we can get that there now. And when you get to this point, you're kind of saying, well, boy, what do we do there now? But hopefully you remember u substitution. And u substitution is says that if you have a u and du showing up in the same equation where you don't have to manufacture a variable or something, then you can actually do u substitution. So what if u was sine theta? Okay, so you see we have sine theta there. Du is cos theta, d theta. So we actually do have that over there. If I need to write it in a little different way, so watch this. I have 1 over sine theta squared times cos theta d theta. Okay, so that looks like u substitution candidate, right? So now I know we're going to u as well. So we went from x to theta to u. So that's okay. We're gonna be able to go back. It's not gonna be a problem because we do have to go back to x, but we're gonna do u here for now. We'll do u, and then we'll get back to theta, and then we'll get back to x. Okay? This is not going to blow your mind. Unless it's like a cool blowing my mind. Like, this is so cool. Blowing my mind is so cool. All right, so this is 1 over u squared, and then this is just du. Now we can integrate. Right? Now we can integrate. This is easy now. And we are kind of pretty much up the mountain. We just have to walk down the other side after this. Okay? So that's, what is that? U to the negative 2. So we add 1. It's going to be negative u to the negative 1, I guess. Right? Plus c. Which really is negative 1 over u plus c. So this is great. This is great. Now we need to substitute u. We need to get rid of u. And we can easily get rid of u and easily put in sine theta, right? So that u is actually sine theta. Now sine theta, we need to write that in terms of x. So everyone with me so far? We got back to sine theta. So we did the integration. We did substitute. Now we're at a spot where we could easily integrate. Now we need to resubstitute back. So now we're in theta. Do I have sine theta anywhere? We didn't start with sine theta. What did we start with? We started with tan theta. Is that a problem? No, it's not a problem. We can go back to our right triangle. No problem. And we can figure out what tan theta is, or what sine theta is from that. So again, our right triangle sort of is going to look like this. Here's theta. Here's the right angle. I know that x equals tan theta, or that's x over 1, isn't it? So what's tan? Well, SOHCAHTOA. SOHCAHTOA. That's opposite over adjacent. Opposite over adjacent. And then what is the hypotenuse then, given these two values? Well, Pythagoras' theorem says that we have 1 squared plus x squared equals hypotenuse squared. So hypotenuse would be the square root of 1 plus x squared. We're almost done. 1 plus x squared. Like really, really close to being done now. So now that I have those three values, I can figure out what sine of theta is. And sine of theta is opposite over hypotenuse. Okay, yeah, you guys can go. Thanks. Just finishing up here with these. Okay, which we have negative 1 over this. So we just flip it, multiply by negative, and we're done. So negative x over root 1 plus x squared plus c. And that is the value of our integral. Ta-da! Okay? All right. I'll give you a couple questions. Yes, I didn't flip it. I said to flip it, and I didn't flip it. Sorry. So it's negative root 1 plus x squared over x. That's what I meant to write. All right. Sorry, a bit of rush at the end there. So yeah, try this one for sure, and we'll do some more examples tomorrow. I hesitate to give you any real crazy examples here yet. So do this one, and then yeah, like I say, if you have some time tonight, just jump on the internet there and grab a couple other ones and give those a try with just simple forms of those 3 forms that we've learned today.